In this lesson, we're going to have a look at the area of what we call special quadrilaterals. They're shapes that are not as common as things like squares and rectangles and so on. Now, the ones that we're going to look at firstly are the rhombus, and this one is given by the formula. The area of this shape here is half times the product of the lengths of the diagonals. Well, the first thing we need to recognize is what a rhombus is. And if you have a look at a rhombus, the key thing about this is that the opposite sides are parallel, but the opposite sides are also equal. So all sides here are equal. So in a way, it's called a square that's being pushed over. And all we need to do is to find the length of each diagonal, multiply them together, and then halve it. So that's the first type of quadrilateral that we'll look at. The second one is the kite. Now, a kite has this type of quality. So you've got two sides here that are equal and two sides here that are equal. And the kite is actually worked out in exactly the same way. We take the diagonal this way and the diagonal this way, multiply them together, and then halve it. So there's the kite. And the trapezium, slightly different one again, is a shape that has got one pair of parallel sides only. Now, the tricky thing with trapezium is getting what we call the height or the perpendicular height. And I'm going to just write that in there as the perpendicular height. And we've got to make sure that in this formula we use that. Now, this is the formula that I like to use, and the probably the easiest way, this is how to get it, this is the easiest way to remember it, is you take the length of the sides that are parallel and opposite each other, you add those together, and then you find the perpendicular height and you multiply that with the sum of the parallel sides, and then you halve it. So if you read it as it is in this particular formula, it's half the perpendicular height times the sum of the parallel sides. And they've said it here, and I'll remind you again of it, and I'll just get a highlighter for this, that the height is the perpendicular distance between the two parallel sides. Now, the other thing that's interesting is that sometimes it is a side, but usually it is not. Now, what they mean by that is, I'm going to try and draw this as best I can, but if I had, oh, let's change that. We'll get rid of that, and we'll just take a pen. All right, so if I had one side this way and one side this way, and that was one of the sides, and you can see where I'm going with this one. We'll just ignore that bit there. But there's our parallel sides. Notice that the side here is the parallel, the side there is the perpendicular height. So the perpendicular height can be built into the shape, or it may not be. So let's do a couple of examples and see how these work. I'll just move this down. We need a little bit more space on the page. So you've got your formulas now, and we just need to apply these formulas to a couple of examples. Here's the first one. We need the area of a rhombus with diagonals that are 5 centimeters and 7 centimeters. Well, the first thing to do is to write down the formula for the area of a rhombus, and we know that it's half times the diagonals multiplied together. And so we don't really need to draw a diagram for this one. Our x value here, one of them would be 5 and one of them would be 7. And it really wouldn't matter which way we put these. You could put 7 first if you wanted to, because it's just taking the two diagonals and multiplying them together. So if you get your calculators out, you can see that this comes down to be 17.5 centimeters squared. Very easy calculation. Once you know the diagonals, it's a very straightforward calculation. Let's try a couple more of these. Here's a kite. Well, they've given you the diagram of the kite, And from here we can read off some information, and we need to know, remember, that the area is the same as the rhombus. So the area is equal to half times the product of the diagonals. So there we go, there's half times, now there we can read it in, so the 5, there's the 5 length, there's 8, so that's that diagonal there, and 5/8 of 40, and half of 40 is 20, and we've just got to make sure we get our units correct each time. So there's a kite. Once again, fairly simple. Once you've got the information, just got to make sure you use the right formula. Okay, let's find the trapezium in this particular case. Now, memorizing the trapezium formula isn't too bad, but here we go. Area is equal to half times the perpendicular height times the sum of the parallel sides. Now, all of that information is in here, so let's write it in. There's the half times my perpendicular height. There it is, 4. Sometimes actually in problems they try and trick you and they'll give you that height there or that height there. They're called the slope height, but you can't use that. They must give you, or we must have to work out the perpendicular height. In this case it's given, so we'll put in here 4 times, now there are the opposite sides that are parallel, 11 plus 16, and once we've got all those in the right position, then we're on our way. So if we multiply all this together, we get 11 and 16, times it by 4, and then halve it. If you check this out, you should get 54 square meters. Alright, so just watch out for that perpendicular height, because that's the part that's that catches people at times. Alright, let's have a look now at our quadrilateral. This is an area of a quadrilateral. Now you'll notice that a quadrilateral is just a general name for a four-sided figure. Alright, so for any four-sided figure, what do we do? Well, in this particular case, we're going to have a look at two triangles. We're going to draw. There's no set formula for something like this. This doesn't fall into a category. It looks a little bit like a trapezium, but the fact is there are no lines marked here to indicate that these are parallel, and you'll notice there's no perpendicular height given either. So what we're going to do is to divide this into two triangles. We just draw one line across from one side to the other, and you'll notice that there's a triangle up here and there's a triangle down here, and if you look at it carefully, you've got all the information you need. So we're going to say that the area is equal to the area of triangle A plus the area of triangle B. So in that case, we can work it out like this. We know that the area of a triangle is equal to half times the base. Now the base for both of them is that distance there, which is 14 centimetres, times, remember, the perpendicular height. So for this triangle, it's that perpendicular height here. So that's triangle A. Plus, now we repeat this part here, half the base times, in this case, there's the perpendicular height down there, which is 5. So we're just about completed. If we have a look at this one, we've got half of 14, which is 7. 7 3s are 21. Half of 14 is 7. 7 5s are 35. So our final answer is 56. Now we need to get our units right. It's in centimetres and its area. So the answer is 56 centimetres squared.